Hello guys, welcome to another video. This one is paper 2-1 of May-June 2016. So let's move on to question number 1. So find the set of values of x for which this is true. So we first have to solve this equation. Let's expand and bring 7 on the left hand side. So let's do that first. So if you expand this, you will get x squared plus 2x minus 4x minus 8 more than 7. Now simplify again, you will get x squared minus 2x minus 8 minus 7 more than 0. Now x squared minus 2x minus 15 is more than 0. So that is your final equation that you need to solve for this set of values of x. Now, as you can see, we have to find the critical values. To find the critical values, we have to equate the same expression to 0. Now we can factorize. So 2 brackets. That will be x times x, and 15 is 5 times 3. To get minus 2, we have to have minus 5 plus 3. So your critical values will be minus 3 and x will be 5. So 2 critical values. Now to find the set of values of x, we have to draw a graph. When you look at this equation, this is positive here, so you will have the shape of a minimum curve. Okay. Now this one is the critical values. This one is minus 3 and this one is 5. So right here we are looking for the regions where it is more than 0. This is your line 0. So more than 0 will be this part and this part. So your values of x will be what? You will say x will be less than minus 3 and x will be more than 5, for which this will be more than 0. That will be question number 1. Now let's move on to question number 2. Illustrate the statements below using a Venn diagram. Okay, so first we have A is a subset of B. Subset means inside of B, and B is inside of C. So pretty easy. We have, let's say we have first one. We have A. It will be inside of B. And then we have B, which is inside of C. Okay, so we have 3 sets in each other. As you can see, A inside of B, B inside of C. This means a subset. Okay, now that is part A. Now part B, it is given that the elements of the universal set of letters of the alphabet, so basically A to Z. Okay, now we have 26, right? 26 in total. The elements of P are letters in the word math, so M-A-T-H-S. The elements of Q are the letters in the word exam. Okay, that is pretty straightforward for now. Now part 1, write the following using set notations. The letter H is in the word of math, so you see H is an element of math. Q set of P. Okay, that will be first one. Now part 2, same thing again using set notation. The number of letters occurring in both of the words math and exam is 2. So number of letters occurring in both math is set P, and Q is equal to 2. Now for part 3, list the elements in the set of P intersecting Q prime. So basically, what is that? If you draw your set, let's say that is P and that is Q. So P intersecting Q prime will be only P and not Q. So if you look at these two words, P is math, so we have M in both, A in both, and this one will be only P. So the elements will be T, H, and S. Okay, that will be part 3 of question number 2. Now let's move on to question number 3. Do not use a calculator in this question, so you have to show every step of your work, right? Part 1. Find the value of this one. Now you have log base of P squared minus. So first thing here, you see the power, we can send the power to the beginning. So you will have minus 2 log of P base P. Now this thing here will become 1. So your answer will be minus 2. That is your answer for part 1. Now for part 2, find this one. Now first thing for you to know is what is log? Lg is just log of base 10. So this is equal to log of base 10. When you say 1 over 10 n, it is just 10 minus n. When you send this up, as you can see here, we have a power. We can send this to the front. You will have minus n log 10 to the base 10, and this will be 1. Your answer will be minus n. Now for part 3, show that this become this, where y is a constant to be found. So we have to combine them together. So whenever you have, so here we have, again you see we have Lg. Lg is log to the base of 10. Okay, so now let's rewrite this down. You will have Lg base of 10, 20. When you have minus, it becomes divide. That will be log base of 10, 5 on top. Divide by log base of 5, 10. Now we have to convert both, this one at least, this one to the base of 10, okay? Because as you can see, your answer needs to be log, it means base of 10. We have to convert this one to the base of 10. So let's do this here. We have this. Now to convert to base of 10, we have to add log of 10 of this value divided by log of 10 of this value. So this will be 1. It will be 1 over log of 10 and 5. So replace this back in your equation. So you will have, on top you will have log of 10 base of 5 divided by 1 over log of 10 base of 5. This is equal to log of 10 5 multiplied by log of 10 5, which is log of 10 5 square. So now if you compare with this one, your answer, the value of y will be 5. So y is equal to 5. Okay, that is part 3. Now let's move on to part 4. You have to solve this equation. So first thing here, you see everyone has the same base of r, so we can combine them together, right? So for this two, when you have plus, it is multiply. You will have log base of r 6x squared equal to log base of r 600. Now since both sides have the same log, can cancel out, you will have this is equal to 600. So x squared is equal to 100. X will be plus minus root of 100, which is plus minus 10. That is your answer for question number 3. Now let's move on to question number 4. So I think in the question, this is your region that has been shaded. Okay. Now let's see, what do we have now? It says the diagram shows 3 circles, centers A, B, and C. So 3 circles given to you. Now each has a radius of 5. So the radius here is 5, 5, 5, 5, 5, 5, which means that this is 10, 10, and 10. And since all the sides are the same, the angle theta will be equal to 60 degrees, right? Which is pi by 3 radians. So that is something we know because of that. Now each circle touches the other circle, and we have this as pi. Great. Part 1 is write down the value of pi. So pi, sorry, it's theta, my bad. Theta is equal to pi by 3 radians. That's the first part. Now for part 2, find the area of the shaded region between these circles. So how would you find that area? Now if you observe, for us to get the area, we first have to find the area of the triangle, and then minus this, this, and this. So these three sectors are the same. Let's call them A, and A. So once you have the area of the triangle, you have to minus 3A to get this region. So let's do that. So how do you find area of triangle? You can just use your formula. So first is number 1 to find area of triangle. You will use half r square, that will be, sorry, this one is not r square because it is two sides. We have 10, 10, right? So 10 square sine theta, that will be pi by 3. That will be your area of triangle. I think the formula is in this way, so it should be half sine of the angle times the two sides of the triangle. In this case, that was 10. So it should be like this. Half, we have to use radians, sine of pi by 3 times 100. That should be 43.30127. Okay, that is part 1. Now for part 2, we have to find the area of A. Area of A is the area of sector of one of the circle. So area of sector. So we can find this easily by using our formula, half r square theta. Half is half. R square here is the radius of the circle, which is 5. So 5 square. Theta is the angle, pi by 3. So let's solve this. Half times 25 times pi by 3. That should give you 13.0899. Now, that is only one of the sector. We need to find the area of 3A because we need to minus 3 of the sectors, right? So times 3, let's see what we get. That should be 39.269908. So finally, from that, you can find your area of the shaded region. So from this area of shaded region should be number 1, which is area of triangle, minus area of 3A's, 3 sectors. Let's see what we get. That should be 4.03. Correct to 3SF. Should be centimeter square. And that will be your question number 4. Now let's move on to question number 5. Do not use a calculator in this question, so you have to show every step of your work in this question. So first one is express this in the form of this, where a and b are integers. So as you guys must know by now, whenever you deal with integers when they are in fraction, and if you want to simplify them, you have to multiply top and bottom by their conjugate. Here you will have this plus 5 and this plus this. So let's see what do we get. Now by simplifying, the top will become, so you will have root of 8 times 7, so 8 times 7, 56, plus root of, that should be root of 8 times 5, that should be 40. Divide by, this one will become, so if you observe, you have this times this, it looks a lot like a minus b, a plus b, which is equal to a square minus b square. So same thing, you have root 7 square minus root 5 square, which is 7 minus 5, and that is 2. So the base will be 2. Now let's see how can we simplify this even more. What is 54? Let's try to divide by 4. 56 divided by 4 should be 14. So you will have 14 times 4 plus, so this is broken down into 14 times 4, and this one should be 4 times root of 10 divided by 2. Now if you simplify this, as you guys know already, root of 4 is what? Is 2. So that will be 2 14 plus 2 root 10. Now you can divide by 2 everywhere. You will have this one cancel out. So your answer will be root of 14 plus root of 10, where a and b are integers. So as you can see, these two are integers, and that will be your answer for part A. Now for part B, given that we have this is equal to this, find the values of p and q for they are integers. So let's do that step by step, right? So on one side we have 28 plus p root 3. And how about this side? Let's expand this side to see what happened. You will have q square plus 4q root 3 plus 4 times 3. Let's simplify. You will have q square plus 12 plus 4q root 3. So now you have to compare the coefficients. So this one is equal to this, and this one is equal to this. So let's form two equations. So first one is q square plus 12 is equal to 28. That is equation number 1. And we have p is equal to 4q. Equation number 2. Now let's solve this to find the value. So what is q square? 28 minus 12, that should be 16. Let's check. 28 minus 12 should be 16. Yep. So q square, so q should be plus minus root of 16. That will be plus minus 4. So now we have two values of q, so it means that we will have two values of p as well. So let's see. For the first value of q, for q equal to 4, p should be 4 times q, which is 16. Now for q equal to minus 4, p has to be minus 16. So these two will be the set of values of p and q for their integers. So here I don't see any condition where it says it has to be positive, so we can take both values as your answer, okay? Because there's no condition based on the values, they're only integers. That's all we know. It doesn't say it is positive or negative, so we can take both values for your answer. That will be question number 5. Now let's move on to question number 6. We have to express this in the form of this, where p, q, r are constants to be found. So we have to complete the squares. So let's do step by step. So what I like to do is I like to rewrite this down as 4x squared plus 8x. I like to leave some space and then write minus 5. Now we have the coefficient of x squared is 4. It is not 1, so we have to factorize this outside. So we take 4 out. You will have x squared plus, that will be 2x. Now next step is you have to take this number, so we have to plus, this number is 2, divide by 2 square. We have minus 5 outside. Now when you add something, you have to minus the same thing. So minus 2 over 2 square. But since it was inside the bracket of 4, you have to take out 4 as well. You have to put 4 here as well. Now we can simplify. You have 4 x squared, so x squared plus 2x plus 1 square minus 5 minus 4 times 1. So simplify. Here we have x, we write x. Here we have plus, we write plus. Here we have 1, we write 1. Here we have square. Now what is minus 5 minus 4? That will be minus 9. So that will be your complete square form, where your value of p is 4, value of q is 1, and r is minus 9. That is part 1 of your question. Now part 2, state the coordinates of the vertex of this graph. So pretty easy. The vertex of this graph will be this value here, 9. So the coordinates should be minus 1 and 9. So you have to understand here, a modulus graph is a graph that it does not go below 0. Now if you were to draw the graph, let's say you have your x and y here, for example, right? Now you have to understand that what it is asking you here, what is the minimum point of this graph? You would say it is minus 9, right? Minus 9 should be below. And for the value of x should be, you have to equate x to this, equate to 0. X should be minus 1. So for minus 1, it should be minus 9. That is the normal, that is the usual graph for this minimum point for the vertex. But now, given that we are trying to draw the modulus of this graph, it will be reflected on your x-axis. It will go up. So for this graph, the vertex will be up, so you have to find this point. This point will be minus 1. Minus 9 will become 9. That's why this point will be minus 1, 9 as your answer. Okay, so that is part 2. Now for part 3, on the axis below, sketch the graph of this, showing the coordinates of the point where the curve meet the axis. Okay, so pretty easy. Same steps I have shown you right here. So let's do that. So first we have to see where it meets the x or the y-axis. Now let me write this down over here. So at x-axis, we know the value of y is 0. So let's solve this. We will have 4x squared plus 8x minus 5 equal to 0. Now we have to factorize this equal to 0. Now let's see what can we use to make this become 8. So we can use 4 here if you want to. Let's use if you can use, yeah, we can use 4, or yeah, let's use 4. Let's see what happens. So 4x, here we have 1 times 5. For us to get plus 8, so I can see it's not possible, right? So we cannot use this one. Let me use a different one then. So you have 2x, 5 is 5 times 1. Now for it to be plus 8, it has to be plus 10 minus 2. Okay, so your value of x could be, so let me write this down here. Oh, here, x can be half, x can be minus 5 over 2. So we have 2 possible points, one where it meets the x-axis. So let me draw a scale for this one. So you will have, this is 1, 2, 3, 4, 5, 1. Okay, so here let's take it as 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4, minus 5. So the first point here we have is half. Half will be right here. And then we have minus 2.5. Should be about right here. That's the 2 points that we have where it meets the x-axis. How about the y-axis? You would say when x equal to 0. So let me find some space. Let me write this down here at the bottom. At y-axis, we know the value of x is 0. Let's see what is the value of y. So you have y is equal to minus 5. That should be 5. So let's use 5 right here. Okay, but you have to understand that the usual point here was minus 5, so it was supposed to go down. But of course, since it is a modulus graph, it will be reflected upwards. That's the where it cuts your y-axis. Now, as you have seen, the coordinates of the vertex is minus 1, 9. So minus 1, 9 should be about right here. Okay. Should be right here. So it was supposed to be down, it was supposed to be here, but it got reflected upwards. Okay, so now we just have to sketch the graph. So it will be like this. It was supposed to be going this way. So it has to be kind of symmetric, but not really. And then it will be reflected upwards because of the modulus sign. So you have something like this. Graph. Okay, so that will be your graph for this y curve. So make sure to label the graph after you're done. -5, and that will be your answer for question number 6. So always to label the points where it meets the axis. This is the point 9, this is half, and this is -2.5. So make sure you do that for your full marks. That will be your question number 6. Now let's move on to question number 7. So we have OPQR of 4 points, such that we have all these points given to you already. Okay, that is good to know. Now part 1 is we have to find PQ. PQ is OQ minus OP. That will be Q minus P. Now part B is we have to find QR. QR is OR minus OQ. OR is 3Q minus 2P minus Q. That should be 2Q minus 2P. Okay, that is part B. Now for part 2, justify your answer. What can be said about the positions of the points P, Q, and R? So let's see what can be said about those two. So as you have observed, we have PQ equal to this and QR equal to this. What happens if you do this? Look at this. If you take out 2, you see that we have Q minus P. It has the same thing inside as this. So it means that so basically PQ is half of QR. We have a multiple basically, which means that if you write this down as a line, you can see that you have a line P joining with R, and the point Q is such that this is Q, the ratio is 1, and this is 2. So what can be said is you can write two things. You can say that the points P, Q, R lie on the same line, or that is called they are collinear, right? Collinear. You can say that. Also, you can say they are in the ratio of this. Or this is the main point. They are collinear. That will be your 2 marks. Now for part 3, given that OP is equal to this and OQ equal to this, find the unit vector in the direction of OR. Okay, so pretty easy. We just have to use this information we just found to find this. Okay, so OP is equal to 1, 3. OQ is equal to 2, 1. So what is PQ? PQ is given by OQ minus 1 OP. That should be 1 minus 2. Now we have to use this ratio here. Okay, so the ratio we know from the first part is PQ is equal to half of QR. So from this you can see that QR is equal to 2 times PQ. That will be 2 times this will be 2 minus 4. Now we have to find OR. OR is equal to, so OR minus OQ is equal to this one. So from this, OR is equal to 2 minus 4 plus OQ is 2, 1. That should be 4 and minus 3. Now we have to find the unit vector in this direction. So pretty easy. That should be just the vector itself divided by its magnitude. So that will be 4 over minus 3 divided by square root of 16 plus 9, which is 4 minus 3 over 5. That will be the unit vector in this direction. You can check. So 16 plus 9 should be what? 25. Root of 25 should be 5. So that will be your unit vector in the direction of OR. And that is your question number 7. Now let's move on to question number 8. So we have to use the binomial theorem to expand this one, giving your answer in its simplest form. So step by step, the first term always is 4 choose 0. We have a, b, so that will be 0, that will be 4, plus 4 choose 1, that will be 1, and that will be 3. 4 choose 2, that will be 2, that will be 2. 4 choose 3, that will be 3, that will be 1, and lastly 4 choose 4, that should be 0, and that should be 4. Now let's simplify. This is 1 times a power 4 times 1. 4 choose 1 is 4, that will be a power 3 times b. And now what is 4 choose 2? We can check. That is 6. 6 times a square b square. Now 4 choose 3 should be the same thing, I think. No, it's 4 times a b cube. That is 1. That is 0. That will be 1 as well. That should be b power 4. Now simplify. You should have a power 4 plus 4a cube b, 6a square b square, plus 4a b cube plus b power 4. That will be the full expansion of this in its simplest form. Okay, that is part 1. Now for part 2, hence find the term independent of x in this expansion. Now if you observe, this is a and this is b from the equation. Now which term will give you the term independent of x? By observation, you would say you would choose this one. Okay, that will be 6. Because of the powers that are the same, they will cancel out. That's why we choose this one. So a is 2x power 2, b is 1 over 5x power 2. That should be 6 4x square 1 over 25x square. So now you observe x square cancel out. So you will have 24 over 25 as your answer. That will be part 2. Now part 3. The coefficient of x power 3 in this expansion equals to this. Find the value of the positive value of n. So let's do that. So if you were to expand this, we will have n. Choose something of your first term and your second term, right? Now for x to be power 3, this has to be 3. If this is 3, this has to be 3, and this has to be n minus 3. So now we know that 1 power anything is 1 anyway, so we can just ignore that. You will have n choose 3. 1 is just 1, that's okay. Here you will have x power 3 over 8. So you will have n choose 3 over 8 x power 3. So this will be the coefficient of x cubed, and this is equal to this. So let's solve. You have n choose 3 over 8 is equal to, so equals to 5n over 12. So let's solve this equation. So first thing we can do is we can simplify. We can divide by 4 on both sides. You will have 2 here, you will have 3 here. So you will have n choose 3 over 2 is equal to 5n over 3. Now you have to look at your formula here for this one. If you go back to your list, n choose something is given by this formula. So let's write this down. So we have n choose r, for example, given to you by n factorial over n minus r factorial times r factorial. But in this case we have n choose 3. So let's replace and see what happens. So n choose 3, you're supposed to have n factorial over n minus 3 factorial, 3 factorial. So in this part you will have that. So now let's replace back in your equation. So we can send this 2 here for now. You will have this, which is n factorial over n minus 3 factorial, 3 factorial. Now 2 will be going up here. You will have 10 n over 3. Now we have to find a way to simplify this part. But first, what is 3 factorial? Let's check. 3 factorial should be 6. Okay, so this will be 6, right? This is 6. But now if you want to simplify, you can do that. You can do divide by 3 on both sides. 3 goes away. That will be 2. And then you can send 2 over here. So you will have n factorial over n minus 3 factorial equal to 20n. So right now we have this equation to simplify. Now for this one you have to understand what is that, right? So let's write this down. We have n factorial is equal to what? N times n minus 1 factorial. Now if you want to simplify more, you can have n times n minus 1 times n minus 2 times n minus 3 factorial, as you can see, right? So if you were to replace this on top of this, let's see what happens. You have n times n minus 1, n minus 2, n minus 3 factorial over n minus 3 factorial equal to 20n. So now you observe these two are the same. These two goes away. Here you have n, here you have n goes away. So finally you have n minus 1, n minus 2 equal to 20. Now we have to expand this. That will become n squared minus 2n minus n plus 2 equal to 20. Now n squared minus 3n plus 2 minus 20, that should be minus 18 equal to 20. Now let's simplify this. 2 brackets as always. N times n. 18 is what? It is 6 times 3. Now to get minus 3, we have to have minus 6 plus 3. So n can be minus 3, n can be plus 6. So your question is asking for the value of the positive n. So n will be this one, 6. And that will be your answer for question number 8. Okay. Now let's move on to question number 9. Given that y is equal to this equation, okay, so it is a tan expression, tan curve, okay. Now it has a period of this. Period is t equal to pi by 4, okay, and passes through this point and this point. Find the values of a, b, and c. So first thing is, how do you find the period of a tan curve? So you have to look at this value. So period t of a tan curve is taking pi dividing by b, right? But we know that this is equal to this, pi by 4, which means the value of b is actually 4. From this, if you solve, b is equal to 4. Okay, 4. Now replace back in your equation, you will have y is equal to a tan of 4x plus c. Now we can use this point to find the other values. This is your x, this is your y. Y is minus 2, a plus tan 0 plus c. So tan of 0 is 0. So from this, c will be minus 2. Now what is the value of a? We can use this one. So to find a, we have to have, so here is x, y. So y is 0. X is a tan 4x pi by 16 plus c. C is minus 2. So let's see what happens. So what does this one become? So tan of 4 times pi over 16. That should be 1. So basically a minus 2 is 0. So a is equal to 2. So here you go. Part 1, a is 2, b is 4, and c is minus 2. That is part 1 of the question. Now for part b, on the axis below, draw this graph for this region, for this domain, right? So we have to see what values do we get. So this one's pretty easy. We just have to find each values of y for the values of x provided. So let's do that. So for the first value, it is minus 2 pi over 3. Let's see what do we get. So 2 times cos 3 times minus 2 pi over 3 plus 1. That should be 3. Now for this one, minus pi over 2. So 2 cos 3 times minus pi over 2 and we have plus 1. Should be 1. And then we have minus pi over 3. So 2 cos 3 times minus pi over 3 plus 1 minus 1. And minus pi over 6. That should be 1. And we have 0. So 2 cos of 0 plus 1. That should be 3. Now next one is pi by 6. So 2 cos 3 times pi by 6 plus 1. That should be 1. So you can see already it should be like that, right? But let's check always, because we don't want to make those silly mistakes. Let's check what the values will be using a calculator. So this will be minus 1, 2, that should be 1 again. And last one, we have 2 cos 3 times 2 pi over 3 plus 1. That should be 3. Okay, so we have these points. We just have to join them to find the values that we have for your curve. Okay, here we have the max point. So make sure you draw your curve as smooth as possible, okay? So try your best. Okay, that will be your curve as required. So y equal to 2 cos 3x plus 1. That will be part 1. Now for part 2, using your graph, otherwise find the exact solution of this equal to 0. Now as you can see, what is this equal to? Now if you want to solve this, you can just do that. 2 cos 3x plus 1 square will be plus minus 1 if you send this over here. So in this case you have two possible values. So first one is 2 3x plus 1 can be equal to 1, or it can be 2 cos 3x plus 1 can be equal to minus 1. So this is what, if you observe, the 2 cos 3x plus 1 is your value of y, which is your curve, right? So basically that is y is equal to 1 and y equal to minus 1. So let's draw this line on the curve and see what are the possible solutions. So now for the first value of equal to 1, it will be right here, this one, y equal to 1, and for the other one it will be this one, right, y equal to minus 1. So the possible solutions will be, for the first one is this, 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 and this, this. So let's write this down. The possible values of x will be, first one according to your graph is minus pi by 2. Then we have minus pi by 3, minus pi by 6. Then we have pi by 6, pi by 3, and pi by 2. So these will be your solutions for this equation. You have 1, 2, 3, 4, 5, 6 solutions. And that will be your question number 9. Let's move on to question number 10. So part A, we have find how many 5-digit even numbers, has to be even, can be made using each of these numbers. So we have 5 numbers, we can use them only once to form a 5-digit number. So the first step is to find 5 spaces where we can put the numbers to form a 5-digit number. Now for a number to be even, it has to end with an even number, right? So here in the list, which numbers are even? You can see we have this is even and this is even. So we only have 2 numbers which are even. It means that we have only 2 ways of ending our 5-digit number for it to be even. Now let's say I choose 2, I'll put 2 here. I have 4 numbers remaining. Now for the rest I can choose anything we want to. So for the first one I have 1, 2, 3, 4 options, so 4 options. Let's say I choose 1. And for this one I will have 1, 2, 3 options. Let's say I choose 3. For this one I will have 2 options, and that will be 1, right? So your number of ways will be 4 times 3 times 2 times 1 times 2. So 4 times 3 times 2 times 1 times 2. That should be 48 as your answer. Now for part 2, find how many different 3-digit numbers can be made using these numbers from this list, if each number can be used only once. So now again, we have to form a 3-digit number. Let's make 3 spaces. 1, 2, 3. So now we don't have any conditions like even or odd, so we can choose anything we want to. So for the first number we have 1, 2, 3, 4, 5 choice. Let's say I choose 1. Now for this one I have 1, 2, 3, 4 choices. Let's say I choose 2. And for this one I have 3 choices. Let's say I choose 3. So your number of numbers will be this, 5 times 4 times 3. So that will be your answer for part 2. Now for part B, a man and 2 women who are to sit in a row of 5 empty seats. So you have to understand that we have 5 seats available. 1, 2, 3, 4, 5. And we're trying to sit one man, so 1 man, and 2 women, so women 1 and women 2. Now the question is if the 2 women must sit next to each other, so we have to put them together. So now let's see, if you want to sit them together, how many ways you have to sit them in this 5 chairs. So we have 2 women, we can put them here 1 way, 2 ways, 3 ways, and 4 ways. So we write down 4 ways. So now let's say for example we put them here. We put them women 1 and women 2. Now from these 3 chairs we can put this man. So we have 3 ways of putting the man in any seat, right? We can put the man here, 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 or here. 3 ways. So now the thing is, we have to multiply by 2. The reason why we have to multiply by 2 is because these 2 women, they are not the same. So in this case, this is first, this is second, but also it can be that woman number 2 is first and woman number 1 is second. That's why it has to be multiplied by 2. That will be 4 times 3 times 2. That should be 24. Okay, that is your answer for part 1. Now for part 2, all the 3 people must sit next to each other. So you have men, women 1, and women 2. All the 3 must be together. So now again we have 5 chairs. 1, 2, 3, 4, 5. So we have 3 people, so you can be sitting here 3. So 1 way, 2 ways, and 3 ways. So you write down 3 ways. Times. Now since they are together, now in this way we have the man is first, 1, women 1, women 2. But if you realize, we can also write this down as men first, women 2, and women 1, and so on, right? There's many ways of arranging them, but since we have 3 different people, you have to multiply by 3 factorial ways. So 3 times 3 factorial, that should be 18. Okay, so just to re-explain, so whenever you have 3 together, let's see how many ways we have of sitting them. So you have 1 way, 2 ways, and 3 ways. Rewrite 3. Now since we have written this in this way, men, women, women, we can also write men, women 2, and women 1. So going forward, whenever you have 3 in one group, you can multiply by 3 factorial to rearrange them. For example here, when you have this, you could have just multiplied by 2 factorial because we have 2 factorial ways of arranging them, but 2 factorial is just 2, so we can multiply by 2, you get 24. Same way here. So now let's say, so just to make you understand this, for example, let's say I had A, B, C, D. So this is not in the question. Let's say I have to make them sit together in this list. You would say I have 4, it can be 1 way, right? It can be 2 ways, you write 2. Now times what? You will have to times, because they are all different, times 4 factorial. That will be 2 times 4 factorial. That should be 48. But this is not in the question. This is just to make you understand, because we have 3 different people in a group together. We have to multiply by 3 factorial ways because we have 3 factorial ways of arranging them in this togetherness. So 3 is for the seating, times 3 for their number of arrangements. That will be 18 for your answer. Okay, so that will be your question number 10. So find this integration. Now we can just do this one by one. That will be 3x minus x 3 over 2 dx. So first thing, we have to increase the power by 1. That should be 2. Then divide by 2. Minus 3 over 2 plus 1. That will be 5 over 2. Divide by 5 over 2. That will be 3 over 2 x squared minus 2 over 5 x 5 over 2. And plus c, of course, for your constant of integration. Now for part 2 is the diagram shows part of the curve y and the lines y equal to 3x and this one. The curve and the line meet the point, meet at the point O, as you can see. That's the first point. And these two lines meet at the point B. At the point A, sorry. Okay, at the point A for the curve as well. But the two lines meet at the point B. Now question is, find the coordinates of the point A. So let's find that. So to find this, we can simply see where this meets the x-axis. So we can use this line. You see this line meets the x-axis as the point A. So you would say at x-axis, as you guys know already, y has to be 0. So you have 0 equal to 27 minus 3x. So 3x has to be 27. X is equal to 9. So this point is 9. So the point A has to be, so 9, 0. That is part 1. Now part 2, verify the coordinates of B are this. So how do you find B? You observe that B is the line here meets with the line here. So we have to find the point of intersection of these two lines. So on one side we have y equal to 3x, and then we have 2y equal to 27 minus 3x. So here we have 3x equal to y. Replace that here. You will have 2y equal to 27 minus 3x, which is y. That will be 3y equal to 27. So y equal to 9. And the value of x should be 3x is equal to 9. X should be equal to 3. So the point B, so first we write the x coordinate, that should be 3, and that will be 9. This is shown as required. That is for part 3. Now let's move on to part 4. So we have to find the area of the region. So the area here is just this one. Is this one according to your question. But now the question is, how do you find this area? Okay, so let's see what can be done. So we have to use our answers that we have found. If you were to draw a line here, a vertical line at this point, we know the point B is given by 3, 9, so this will be 3. Now you first can find this part first and then find this part. Now to find this part, if you look at only this side, so let's forget about this side, right? So what would you do? So this side is what? It is a right angle triangle. For the big area, it is a right angle triangle. That is the whole area. And then you have to minus the area below the curve. So let's find this part first. That will be part A. So the whole area is area of a triangle. Half times base, which is 3, times height, which is 9. That should be 27 over 2. Now we have to minus area under curve, which is equal to integration between 3 and 0 of the curve, which is 3x minus x 3 over 2 dx. So now for this one, we have done this already in part 1. We just have to replace back in the equation. You will have equal to 3 over 2x squared minus 2 over 5 x 5 over 2 between 3 and 0. So now let's solve. So you will have 3 over 2 times 9 minus 2 over 5. That should be, so 3 power 5 divided by 2. That should be what? So I don't see we can have any kind of fraction here. So let me see if we have any conditions. So no. So your answer can also be in decimal place. It doesn't need to be exact. That will be here, and that will be 3, 5 over 2. and minus this will be just 0. So let's see what is this breakdown to. So 3 over 2 times 9 minus times 9 minus 2 over 5 times 3 power 5 over 2. That should be 7.2646. So now for the first part is we are trying to find this area. Let's call this one A. To find A, we must have to take the big one minus area below the curve. So basically A will be area of triangle, which is 27 over 2 minus area below the curve. Let's see, what do we have? That should be 6.235. That is for part A. Now for part B, the same thing as well. You can observe here we have a big triangle, which is base of 6 and height of 9, and then we have to minus area below the curve for this side. So now let's do for part B. Now for part B, the whole area is area of triangle as well. Half times base, it is 6 this time, height is 9. That should be 27. Now area under the curve, area under curve this time is the same integration, but between 9 and 3. As you can see, we have to find the area below the curve from this to this. So we have to minus this side, right? So that will be 3x minus x, 3 over 2 dx, which is equal to the same thing we did before, which is 3 over 2 x squared minus 2 over 5 x power 5 over 2 between 9 and 3. So let's simplify. You will have 3 over 2 times 81 minus 2 over 5 times 9 5 over 2 minus 3 over 2 9 minus 2 over 5 3 5 over 2. So let's see what happens. 3 over 2 times 81 minus 2 over 5 times 9 power 2.5. So the first part here will be 24 3 over 10 minus this one is should be the same thing as above. As you can see, should be this one. So 7.2646. Now this minus this should be what? 7.2646. That should be 17.0354. Okay, so that will be the area under the curve, right? So now we have to take this area minus this to find the area of part B. So there you go. Area B is 27, area of triangle minus area below the curve. Let's see what happens. 27 minus answer, that should be 9.965. So finally, area of shaded region will be A plus B. A is 6.235 plus 9.965. 6.235 plus 9.965. That will be 16.2 centimeter. I think this will be units square. Okay, so that will be your question number 11. Okay, now let's move on to question number 12. That is your last question. A curve have the equation of this. Find dy by dx. So pretty easy. The first one is what? Is a fraction. So we have to use your quotient rule. So dy by dx is equal to x minus 1 times 2 minus 2x minus 5 times 1 divided by the square of the base, minus 12. That will be dy by dx. Now you can simplify if you want to, but if you don't want to, that's okay as well. Here you will have 2x minus 2, then minus 2x plus 5 over x minus 1 square minus 12. It is equal to, let me use a different color here for this evaluation. You will have this to cancel out. You will have 3 over x minus 1, 2 minus 12. That's dy by dx. Now we have to find d2y by dx2. So you can rewrite dy by dx as what? As this. 3. Send this power up. You will have x minus 1 power minus 2 minus 12. Now to find d2y and dx2 is pretty straightforward with this. So first we have to multiply by the power. So minus 2 times 3 x minus 1. Have to minus 1 to the power and times 1 for the differentiation of the inside. Then this will become 0. So your answer will be minus 6 over x minus 1 cube. That will be d2y by dx2. So now for part 3, find the coordinates of the stationary points of the curve and determine the nature. So pretty easy. To find the stationary point, as we know, we have to look at dy by dx is equal to 0. We know that dy by dx is equal to 3 over x minus 1 square minus 12 is equal to 0. Now we can just send 12 over here. You will have 3 over x minus 1 square equal to 12 over 1. But now you can divide by 3. You have 1. You will have 4. So your equation becomes 1 over x minus 1 square equal to 4 over 1. Now let's simplify. You have 1 on one side by cross multiplying. Here you will have 4, and this will become x squared minus 2x plus 1. That is 1 equal to 4x squared minus 8x plus 4. Now simplify. You have 4x squared minus 8x. So now we have to send this one over here. So you become plus 3 equal to 0. Now let's factorize and see what is the possible values. So we have 4x here. We have x. 3 is 3 times 1. So here we need minus 8. We can have, so it will not be possible this way. So let's try something else. Let's try to refactorize using other factors. 4 is 2 times 2, so 2x times 2x. And here we have 3 times 1. So to get minus 8 has to be minus 6 and minus 2. Okay, so now it is a good factorization. If you check, minus times minus should give you plus, so that is good. Now x is equal to what? Half. X can also be equal to 3 over 2. Now we have to find the corresponding values of y for each point. Now going back to the equation, y is equal to 2x minus 5 over x minus 1 minus 12x. Now for the first value of x, what is the value of y? You would say that will be 2 times x. 2 times 0.5 minus 5 divided by 0.5 minus 1 minus 12 times 0.5. So basically I'm just replacing this value in the equation to find the value of y. Okay, so you will get 2 for this one. How about this one? This is 3 divided by 2, which is 1.5. So 2 times 1.5 minus 5 divided by 1.5 minus 1 minus 12 times 1.5. That will be minus 22. So here, as you can see, you have two stationary points. The first point is, let's write it down, stationary points on this curve. The first one is 0.5 and 2. And you have 1.5 and minus 22. Now we have to find the nature of each point, so pretty easy. First one, let's write this down for this point. The value of x is 0.5. To find the nature, we have to look at d2y by dx2. So d2y by dx2 is given by minus 6 over x minus 1 cube. Now let's replace this value in this equation. You will have what? So d2y by dx2 when x is equal to 0.5. Let's see the value. That should be minus 6 divided by 0.5 minus 1. That should be minus 0.5 cube. That will be 48. So since the value is a positive value, it means that this point is a minimum point. So now logically this one will have to be a maximum point, but let's check to show them that you have shown that it is a maximum. So same way, that will be 1.5 and this will be minus 22. Now for x equal to 1.5, we have to find d2y by dx2. When x equal to 1.5, that will be minus 6 over 1.5 minus 1 cubed. That should be what? So minus 6 divided by 1.5 minus 1 power 3. That should be minus 48. Now since the value is negative, there has to be a maximum point. So here you go. This is how you find your points, by doing dy by dx equal to 0. And then once you have your x, you have to find your corresponding values of y. And once you do that, you have to find the nature by using d2y by dx2. You have the minimum point and a maximum point for these two. So that will be your last question of this paper. I hope that was somewhat helpful. As always, thank you for watching, and I will see you soon.